Hello and welcome back to SAS From Scratch. Today's episode is episode 10, which corresponds to chapter 10 in the SAS-based prep guide. And we're going to be looking at the set and merge statements today to see how we can combine different data sets with one another. Now, we're already quite familiar with the set statement. We've used it in, I believe, every single episode that we've done so far. And the set statement is essentially a read command that says take a particular row from a source data set and place it into the PDV. And then as soon as the data step iterates, we'll continue with the next row until we reach the end of file marker. So when we know a little bit about the set keyword or set statement by now. We're going to see how we can use it to combine data sets. And then we're going to learn about a new statement, which is the merge statement, which allows us to join data sets. Now there's three we're going to look at today. The one-to-one reading is not used too often in my personal experience, but we will take a look at it because you do have to know it for the SAS base exam. And that uses the set keyword. We're going to look at concatenation, which is essentially stacking data sets. That's a vertical operation, similar to the bind rows function in R, and for that we'll use the set keyword again. We're also going to be looking at match merging. That's similar to SQL join, or if you're coming from R, your dplyr joins. And it's a horizontal operation. So you've got something on the left, you've got something on the right, and you merge them into one another. And for that, we're going to use the merge keyword. So we've got these three ways of combining data sets in SAS, and these are the three that we need to know for the base exam as well. We're going to start with the one-to-one reading. The image that you see here is taken from the SAS-based prep guide, 5th edition, chapter 10. The illustrations are very useful. Also in the prep guide, they've got very good visual representations of what is happening in the PDV, how SAS, for example, is finding matches between by groups when you merge, etc. So definitely your prep guide is a vital supplement. No, it's really the I would say these videos are probably a nice supplement or complement to the prep guide, not the other way around. So make sure you go and review this chapter in the prep guide as well. Okay, so when we talk about a one-to-one reading, we have to understand how SAS processes data and how SAS places data into the PDV. Here we are again with the PDV. We're going to talk about the PDV ad nauseum because it is the foundation, the bedrock of how SAS processes data. In the example we've got here, we've got two data sets. We've got a data set with a number column and var A, and we've got a data set with a number column and var B. And a one-to-one reading, and we saw in the last episode, we tried to learn a bit more about how the set statement is essentially just an instruction to read data. And so when we have these two set statements within a data step, we're essentially telling SAS to read a row from data set 1 and read a row from data set 2 and place both of them into the PDV. So if we look at what is happening in these two first rows for each of these data sets, and just to point out, please notice the syntax that there are two set statements and each of them is ended with a semicolon. We'll look at the difference between this and concatenation on the next slide. For now, please notice there's two of them here. and you could add even more if you wanted to. So let's imagine this is the first dataset 1, this is dataset 2 on the right. If we issue the read instruction to SAS, SAS is going to place num with the value 1 into the PDV. It's going to place var a with the value a1 into the PDV. SAS then encounters our second instruction to read from dataset 2, which is on the right. SAS still has only a single record in the PDV because it's a row-based system and it can only do one row at a time in the PDV. So SAS will now overwrite num equals 1 with num equals 2, and it will add var b with value b1 into the PDV. And so that is what is happening here with the first row being processed. Number 2 replaces number 1, and we take A1 from the left dataset and B1 from the second dataset. A similar process happens for the second row, where first SAS reads in the value of num as 3, the value of var a is a2. Then SAS gets the second read instruction to read from this dataset on the right hand side. It replaces num equals 3 with num equals 4, and it adds the value var b equals b2 to the PDV, and it writes that out. Now, the problem that we have with one-to-one readings is that if these two datasets do not have the same number of rows or observations, SAS will halt the execution of the data step as soon as it encounters an end of file marker. So in this dataset on the right hand side, the end of file marker is reached after record number 2. When SAS iterates for the third time in this code that we have here, it reads the third record from this dataset on the left hand side. The value of num is set to 5. The value of var a is set to a3. So that is what is contained within the PDV. SAS then tries to read from the dataset on the right hand side. SAS encounters the end of file marker and halts execution immediately. So this number 5 and var a equals a3 is still within the PDV, but it is never written out because of the fact that the execution is immediately halted. The interesting thing to notice here is that when we do a merge with the merge statement, we'll be merging on something. So we'll be merging, for example, the number 1 in here with the number 1 on the right hand side. In this case, all we're really doing is we just reading the first record from every dataset as much as we can into the PDV and filling it up. Then we move on to the second record of every dataset, read them into the PDV, fill it up, make it bigger and bigger, write out that record. But the problem is that if you've got variable names that repeat, the value will be the most recent statement's value, the last one, because you're still dealing with the PDV, you're still dealing with one row at a time only. And if that does not make sense, you need to go back to episode 1 of this series, and you need to go back to chapter 7 in your prep guide. So that's one-to-one reading for combining datasets. The next method of combining datasets that we're going to look at is concatenation. Excuse me. And for that, we're also going to be using the set statement, but it's going to be a little different. So note how in the last set, and in the last example, we had a set statement for dataset 1, semicolon, set SAS dataset 2, semicolon, whereas in this case we have a single set statement, we have a single semicolon, and these datasets are just added in there in between. So you could have had dataset 3, 4, 5, as many as you wanted in here, and SAS will just concatenate them. So what that means is SAS is not going to replace, if you've got, like in this case, we've got the variable num twice. SAS doesn't replace those. It just reads all the records from the first data set, outputs them, reads all the records from the second data set, outputs them. And you can see the example here. We've got number 1, 2, 3. Var A is A1, A2, A3. So they're neatly encapsulated here. And for the second data set, we've got num1 to 4. Var B is B1, B2, B3. And you can see that they're just stacked below the first data set. So for the columns that did exist in both, they'll just continue on. If a particular column, var B, for example, did not exist in this data set, the values will simply be missing. Var A did not exist in the second data set, the values will simply be missing. But it's a very simple way of just stacking two data sets on top of one another. As long as you keep the correct syntax in mind and don't confuse it with the one-to-one reading, shouldn't be any issue. The third way of combining data sets is to merge them. So SAS calls this, in the base prep guide, they refer to it as match merging. If you talk to people, they'll just call it merging. This is the same concept as a SQL join or the dplyr joins in R, as we've said. The syntax that we've got here is we've got a merge command or statement. We've got all of the data sets that we want to merge. It doesn't have to be only 2, we can have 3 or 4 in here. And then we simply say by what particular variable we want to merge them by. The important thing to notice here, what's different from our set methods of combining data sets, is that we've got a by statement. So SAS will, in this case, if we do a merge by num, SAS is going to try and match the instances of num1 with num1, num2 with num2, 3 with 3 doesn't exist, and 4 doesn't exist on the left-hand side. So what will happen in that case is where SAS can match these, it will. So it'll take num1 with var A1 and B1 from these two data sets and place them into a single row. For num2, it will do the same. It will take A2 and B2. For 3, there is no match in the right-hand side for this particular by group ID, which is number 3. So it'll take the one from the left-hand side, and this column will simply be missing for the right-hand side. And likewise, when it processes num4, there is no match for num4 on the left hand side, so it will grab B3 and it will keep var A as missing. This should be quite straightforward for anyone who's worked with SQL joins or dplyr joins before. The thing to keep in mind is that this statement, as you see it here, is essentially the equivalent of an outer join. I think it's also called a full join, if I'm not mistaken. But essentially, it will keep as many of the values and as much of the data as it can, even if there's missings. And we'll see how we would do the equivalent of a left join, a right join, and an inner join with the merge statement. It's fairly straightforward. This slide and the content that's on it is not part of the SAS base exam. ProcSQL is considered an advanced topic in SAS, and it is part of the SAS Advanced certification. SAS does support SQL joins if you prefer those via the ProcSQL procedure. So that's another new proc that you can go and investigate in your spare time. It has inner joins, outer joins, lefts, rights, and it's got the very useful cross join as well, which is the Cartesian product of two or more data sets essentially. If you're not familiar with what the Cartesian product is, that is a concept from set theory. So if you've got two sets A and B, then it's essentially all of the elements in set A paired with all of the elements in set B. So if you've got in set A, let's say in set A you have the letters A, B, C, and in set B you have the numbers 1, 2, 3, then the Cartesian product of that would be A1, A2, A3, B1, B2, B3, C1, C2, C3. And that cross join or Cartesian product is very useful sometimes if you need to create a perfect data set, for example. By a perfect data set, if there's missing visits or missing, again in the healthcare sector, as an example, if you want to make sure that each subject has a row for every possible visit combination, then you could use something like a cross join. There's other ways of doing it as well, but a cross join is super fast at doing it. SAS supports extra set operations, and now here we have to just be careful. We're talking about set theory once again. We're not talking about just the set statement, which we're very used to. So these set operations, if you've studied set theory before, you'd know that the union of two sets will take all of the elements of one set and combine it with all of the elements of another set. So if we go back to our earlier example where set A contains the letters A, B, C, and set B contains the numbers 1, 2, 3, then if set C is the union of A and B, it will contain 6 elements, which is A, B, C, 1, 2, 3. And union by default discards duplicates unless you use the keyword all. Sets in set theory do not allow for duplicates. Elements are unique, they are distinct, and you can get around that by using what is called a multi-set, which is essentially a set that allows for counts of these different elements. So an element can exist for several instances in a multi-set, but not in a normal set. And because this is a set operation, if you do a normal union, SAS will discard those duplicates unless you use union all. There's extra things like outer union, which does not overlay your columns. So if you've got columns of the same name, SAS will instead of doing a normal concatenation, which is what a union is, instead of doing a normal just concatenation, SAS will keep those two columns separately, even if they've got the same name, and will presumably rename the column. The except and intersect keywords in ProcSQL are also very useful. It gives you a way of checking which rows are in one data set but not in another data set. It gives you a way of also checking the intersection between the two data sets. So which records occur in both data sets and discards what doesn't occur, between the two of them. There's extra keywords there I'm not going to go into now. The all keyword obviously prevents you from discarding duplicates. The correlation keyword is something that you'll almost always use because you want to compare a particular column with another column. Otherwise, SAS will look at the order in which those columns occur. But that's not part of SAS base. These operations do exist, and I just want to make sure that if you're viewing this and you ever have a need of these set operations, that you're aware that there's they do exist and there is an alternative. That's basically it for the combining of data sets. I've prepared a very quick exercise that we can look at, just to do a very quick run through of these data sets. So we've got an imaginary company which is called ABC Pharma. They are running a clinical study and they've given us 4 data sets. We've got our demographics split across 2 parts for some silly reason probably. We've got some vital signs data. Recall that that's your heart rate, your blood pressure, that sort of thing. And we've got a data set which contains the enrollment dates for each subject as well. So when did they actually enroll into our clinical study? We've got 3 different operations that we're going to perform. We're going to stack the 2 demographics data sets, the 2 different parts, so that we get a nice unified data set. We're going to then do a one-to-one reading between our new demographics data set and the enrollment data set. We're going to delete one of the rows and we're going to see what happens. We're also going to explain what is the state of the PDV when that, after we've deleted that row and what the case is. And then we're going to do a merge. We're going to merge the demographics data set with the vital signs data set, and we're going to play around with the different kinds of merges that we can do as well, whether it's an inner join, outer join, a left or a right join. We're going to see how we can perform the same thing in SAS with a merge statement. So let's get started with that. Let's do the first item. Apologies, I have now been logged out. Let's do the first item, which is stacking the 2 demographics data sets. Cool, back. Let me also move myself over this way. There we go. So I've taken the liberty, as always, of getting us started with a code file, episode 10.sas, and we have got a library being mapped here. So episode 10 points to this folder we've got here, and notice that except for this, the SAS program file here, we've got a vitals data set, an enrollment data set, demog1 and demog2. And that's what we're going to be working with today. So let's start by just splitting our code neatly into the 3 items that we have to do. So we've got concatenation, we've got a 1-to-1 reading, and we've got merging. And we're going to start by concatenating, we said demog1 and demog2, so that we have one unified data set. So let's look at demog1. It's got subjects 1, 2, and 3. They've each got their own particular age and sex. We've got demog2, which has subjects 4 and 5, also with their unique age and sex recorded. So we want to stack these 2 on top of each other so that we get a unique data set. Let's simply call it demog, and that's going to be set ep10.demog1 with ep10.demog2. You can write it in one line. Recall that you can split a SAS statement over multiple lines as well, and SAS will see it as a single statement until it encounters the semicolon. So I like writing the concatenation operations like this, simply because it's more readable than having it in a single line. And what we would, so there's our error. The library has not been assigned. We just need to run the libname statement as well, because this is the first time that we've started the SAS session now. Or the first time we've run this program after the SAS session has started. So if we look at the output data, we've now got a data set called demog. We've got all the subject IDs stacked on top of each other, as well as their age and sex data. The one thing that you may want to keep in mind is, in this case, our data was already sorted properly. So we had 1, 2, and 3 in the first data set, and we had subjects 4 and 5 in the second data set. In real life, you might want to just make sure that your data is sorted in a manner that's readable, or in a way that, you know, if you're going to do a by group on subject ID, you'll want to make sure that you sort by subject ID first. So that's our concatenation. It's that simple. The next item we need to look at is the one-to-one reading. We were asked to take this enrollment data set, which has one row for subjects 2, 3, 4, and 5 each, and a particular enrollment date. And we were asked to do a one-to-one reading between this and the new demographics data set. Now I want to ideally have this be nice and visible what we're doing. So let's start by just reading our enrollment data set, because we know we're going to have to edit it down the line. We know we're going to have to drop subject 4 was the instruction. So for now, let's just do this and put it into the work library where we can edit it and change it. Then let's do that one-to-one reading. So I'll create a new data set that's called demog enroll, which is the one-to-one reading between demographics and enrollment. And I'm going to point it to this demog data set in the work library and this enroll data set in the work library. So I'm going to issue 2 set commands. Notice the difference between one-to-one reading versus concatenation. And recall what happens. We read the first row from demog, put it into the PDV, read the first row from enroll, also try and put that into the PDV, possibly overwriting values where the variable names are the same. So let's run this. This is our enroll data. It's a pure copy of the one that's in the EP10 library. It's now just been placed into the work library. And this is our one-to-one reading. So we've taken the first row from the demog dataset and just combined it with the first row from the enrollment dataset. This use subject ID value here is from the last dataset that we read in. So if this dataset was not correctly sorted, if this was subject 5, 4, 3, 2, 1, we would have simply overwritten this with 5, 4, 3, 2, 1, even though age and sex are still for subjects 1, 2, 3, 4, and 5. So that's why this one-to-one reading is, in my opinion, it's a bit of a flaky operation. I don't really enjoy using it, and I rarely use it in real life, but it is important to know for the SAS base exam. Now, something that I want to do is, before we delete subject 4 and run this code again, is to say print datasets and enroll datasets for me. I'm just going to do that here. And then we're also going to print the output dataset. And the reason why we're doing that is because that's just going to be easier to keep track of than constantly jumping in between the three datasets that we're using here. So we're still busy with our one-to-one reading. I'm now going to delete the row for uSubject ID 4. So I'm going to say if uSubject ID equals 004, then delete. Recall the delete statement from our last episode. And if I run this, I now have subjects 1, 2, 3, and 5, and we've deleted subject 4 from this dataset. I'm going to print the demog dataset. I'm going to print the enroll dataset that's now missing subject 4. We're going to do our one-to-one reading, and we're going to see how that, how deleting subject 4 has affected the output of the one-to-one reading. Okay, so this is our demog dataset. You can see there's our agent 6. This is our enrollment dataset. And you can see that we've only got 4 records here now. We're missing subject number 4. So we jump from 3 to 5 immediately. And then this is our one-to-one reading result. Notice that everything is fine up until record number 3. We've only got 4 records instead of 5. So here, the end of file marker is encountered and the data step terminates after 4 records. The other problem we have is that subject 4 was a 50-year-old female, which is correct. But because we're doing a one-to-one reading, it's matching observation number 4 in this dataset with observation number 4 in that dataset. And so we're overwriting the subject ID with 5, even though it was initially read as 4. We're keeping age as 50 and sex as female, but we're bringing the enrollment date up as the 7th of March. So we are now mixing data for subjects 4 and 5, which is not correct. And this is something that you need to be very careful of when you use this one-to-one reading. One of the questions was, what is the state of the PDV? When we read in subject 4, we start by reading in the demographics dataset. So uSubject ID is 004, age is 50, sex is female. We then issue another set statement. So we read uSubject ID as 005. That replaces the value of 004, and it adds the value for enrollment date as 7 March 2023. That is then output as the 4th observation in our output dataset. SAS reads this 5th dataset, which is also uSubject ID 5, 49-year-old male. SAS tries to read a 5th observation from this dataset. It cannot because there's an end of file marker. And even though this data is in the PDV, the data step immediately terminates and never reaches the implicit output statement to output anything. And that is the state of the PDV at the end of this execution. I hope that is clear. The next instruction that we had was to merge the demographics dataset with the vital signs dataset. So let's do that. And merging and concatenation is the two instructions or operations that you'll use on a day-to-day basis. One-to-one reading, not so much. So we've got our demog dataset, which is the subjects from 1 to 5. We've stacked these two on top of one another. Our vital signs dataset looks like this. We've got 5 records per subject. So each subject came in for 5 visits. We've measured the height, the weight, and the systolic and diastolic blood pressure at each visit. And you'll notice here we've got subjects 1, 2, 4, and 6 in this data set. Recall in our demographics data sets, it's 1, 2, 3, 4, 5. So this data set is missing subjects 3 and 5. The other data set is missing subject 6. And we'll see when we merge these two data sets together what the result is. We are going to use our merge keyword. And because I'm doing an outer merge, I'm just going to call this data set outer merge. What do I mean by that? We're going to take as much data from the left data set and as much data from the right data set as we can. So if we say merge demog with ep10.vitals, and we do that by useSubject-id, what is important to remember when we use a by statement? Our two data sets need to be sorted by whatever we specify here. So demog needs to be sorted by subject ID and vitals needs to be sorted by subject ID. They are. So this subject ID here runs in ascending order and the subject ID in demog also runs in ascending order. And so the way that this merge works is, and I'm quickly going to jump back to the slides. The way that this merge here works is SAS will, and I think I have said this, when you create this by group, SAS starts here at this row, tries to find all the instances on the other data set where that by group matches, and then outputs that to the output data set. Then it'll move on to the next one and try and do the same thing. And because we're doing an outer merge, it'll take bits from the left and bits from the right and try and find matches for the by variables between the left and right. So if we run this outer merge, notice that for subject 3 and subject 5, I wonder if it'll let me highlight both. Yeah, there we go. So in subject 3 and in subject 5, we only have the single demographics record. We don't have a visit number with vital signs data, because in this vital signs data set, we don't have rows for subject 3 or subject 5. So where we could find matches for subject 1 and 2 and 4, we have it. Notice also that for subject 6, who appears in the vital signs data set, but not in the demographics data set, we're missing the age and sex data. So this is an outer join. It tries to get as much data as it can from both of the two data sets. Now, what we can do is an inner join, which is a very strict join, a very strict way of merging two data sets. And that is going to look only for by values that are in both of the data sets. So that should only then give us, sorry, this is the wrong data set. That should only then give us rows for subjects 1, 2, and 4. Because subjects 1, 2, and 4 are the only subjects that appear in both data sets. And the way we do that, and I'm going to call this merge inner merge, or this data set that we're going to output, I'm going to call inner merge. And I can actually just copy what we did before for the outer merge. And what we're going to do differently this time is to add an in option. And what this is similar to the first dot and last dot flags that we worked with in episode 8. SAS will create these little markers that say, okay, this record in the output data set, so in inner merge, the demog data set contributed to this record. And once we have that, we can then filter on that and say, okay, well, give me only the rows where both of these contributed or where one of these two source data sets contributed. So if I say I want to create this little flag variable called inDemog for when a variable was coming from the demog data set, and I want to create a variable called inVitals when a variable was coming from the vital signs data set, I can then go and filter on that afterwards, and I can say if inDemog and inVitals. And what this does is, if you create this in flag with a by group, it will specifically check that this dataset contributed a particular uSubject ID to the output dataset, and the same for the vital sign dataset. So this filter is essentially saying if a uSubject ID occurs in both the demog and the vital signs datasets, then only keep that record and filter on it inclusively. And if we run this, notice we've got subject 1, we've got subject 2, and we've got subject 4, because these three subjects are the only subjects that occur in both of these data sets. That's our inner join, what I've called here inner merge. Now, a quick question, if you have been paying attention in some of the previous episodes, is what happens if we replace that if statement with a where? You can pause the video here, you can think about it for a second, and then you can come and check your answer. I'm going to proceed in the meantime, and I'm going to run this. Notice that we get an error, and we're told that this variable does not exist. The question is, why does that variable not exist? Because this where statement executes before the processing starts, before things are loaded into the PDV, before these flags are created. So by the time this where statement executes, these two values, flags, do not exist yet. So we have to use an if statement to accomplish what we need to. Now if you've been paying attention, you've probably already asked yourself, what if we keep only inDemog or only inVitals? That's essentially going to be your left join or your right join. If we say, okay, demog is our left-hand data set and vitals is our right-hand data set, we can simply, and I'm just going to copy and paste these because it's going to be faster. If we change this to what we call a left merge, we would simply make this inDemog, and now we will keep all of the subjects that are in demographics, but if there's an extra subject in vitals like subject 6, it's going to be discarded. So if we run this, notice that we've got 1, 2, 3, 4, 5. Subjects 3 and 5 are not in the vital signs data set. That doesn't matter. We've said as long as they're in the demographics data set, we want to keep them. We can do a right merge, and I'll talk about the naming of these variables just now because it's not strictly left and right. We can swap these around. You know, you can put oh, that's not right. You can put demog, for example, on that side. As long as you just say in demog, you're going to get the same result. So there's not strictly a left and a right as you would have in SQL. For the purposes of this demonstration, I'm just calling it left and right. So if we wanted to do the equivalent of a right merge, then instead of saying in demog, we would simply change this to in vitals. And we would then keep whatever records are in whatever subjects are in vital signs, because that's our group by, and we would throw away any subject ID rows from demographics that do not correspond. And again, to reiterate, this isn't strictly left and right. That's just my way of explaining this. So we know that in our vital signs dataset, we did not have subjects 3 and 5. They do not appear in this new merge that we've created. Subject 6, who is not in demographics, does appear with missing values for age and sex because he or she does not exist in the demographics dataset. And that is essentially the 3 different ways that you can combine SAS datasets with one another. So we've got our concatenation, which is super simple, our one-to-one reading, which requires a good understanding of the PDV and is not used very often. And then we've got our merging, which is similar to a SQL join and is used very often. Likewise, also concatenation is used very often in day-to-day operations. So that wraps up the exercise that we did, exercise 10.1. Let me move myself back here to the side. There we go. That wraps up the exercise. We've I think answered all of these questions. And I hope that the different ways of combining SAS datasets is now clear. Next time in episode 11, we're going to be looking at the do keyword. Now, the first item there, we've already kind of jumped the gun in episode 9, because we've already seen how we can combine do blocks with if then else blocks to execute multiple lines of code in if an if statement conditional is evaluated to be true. However, the do keyword can also be used for iterative do loops. So that's, do from I is 1 to 10 and do something. We're going to look at nested do loops. So you can put one do loop within another one. And we're going to look at the do while and do until statements or functions as well. That's, however, for next time. Thank you very much for watching. As always, feel free to leave a like or a comment. If there's anything that I can improve on, subscribe if you want to be notified when the next episode drops. It's going to be on a Monday and a Thursday going forward. But until next time, hope you have a good day. Cheers. Bye-bye.